30s. I hope everybody's doing okay with the first week of doing school online. I know it must be crazy for everyone, but let's see how this first week goes. I just got a quick video on buffers here, so you should have be finished the part one notes for chemistry at this point. And I think we need a little bit extra explanation on the concept of what a buffer is. So what a buffer is exactly, a buffer is a weak acid or a weak base that will help a solution or a substrate like soil resist a change in pH. So if I were to add a bunch of acid to my soil through acid precipitation, I would want it to withstand that drop in pH, which could cause a whole bunch of problems for my ecosystem. So let's illustrate that in a little bit different way here. So let's look at these graphs. So these are called titration curves, which we are going to learn about. In the first graph here, I have a base, and I am slowly adding some acid to that base. And I'm going to actually reach a point where I've added enough acid that my base is totally neutralized by my acid. So I actually have excess base up here. I add some acid, and then I get to a point where that base has been neutralized. That's called the equivalence point. Now, any acid I add after that point, right, that's a neutral pH. Any acid I add after that point is going to be excess acid, and I'm going to and this is going to result in a drop in pH. So if this is the soil in your ecosystem, or let's say you're a farmer, that's not a good thing. Soil or water that has buffers, the positive of having a buffer in your soil or in your water is this section of the graph here that I'm drawing right now is going to be a lot longer. And so basically what that means is I can add more acid to my water or my soil without affecting the pH. And this is really good. Now in Alberta, we have a unique situation. In Alberta, we are built on limestone. And that limestone is a mineral called calcium carbonate. And when calcium carbonate dissolves in water, it produces calcium ions and also carbonate ions. Now, those carbonate ions, that is a weak base. And that weak base in our soil is going to act as a buffer for us, and it's going to help us withstand acid precipitation, changing the pH of our soil and protecting our ecosystems that way. Here's an example of a Bronsted-Lowry equation with that. So let's say I have my carbonate ions that come from limestone, and I'm going to add some hydronium ions from acid rain to that. Now, what's going to happen is that hydronium, remember, is acting as an acid. It's going to donate a hydrogen ion to my base. And that carbonate ion is now going to become a hydrogen carbonate ion. And we need to think back. We're balancing the charge, and we're balancing all the atoms in our equation here. So after hydronium gives up a hydrogen, it becomes water. And in this case, after acid rain falls on Alberta, the carbonate ions in the soil are going to act as a buffer, and they're going to protect our ecosystem from having that drop in pH. Now, what happens when we have that drop in pH? Just a reminder, things like leaching of minerals and nutrients from the soil. We have aluminum ions. We have heavy metals that can get leached out of the soil into water. And having this carbonate in our soil is going to protect us from that leaching. And one other thing, just to remember why it's okay to be in Alberta in terms of acid precipitation is there are these winds that are pushing nitrogen oxides and sulfur oxides from west to east across our province. And that is called the jet stream, and the polar vortex also helps with that as well. So in Alberta, we have a unique situation that we want to know about as well. So that's a little bit about buffers. I hope that helps you guys. I'll talk to you next time.